Hello, Algebra 1 students, and welcome to your second lesson in Topic 6, Exponents and Exponential Functions. Our first few lessons here are really just going to be on exponent rules, different properties of exponents, what certain types of exponents mean. Our first lesson, lesson 6.1, reminded you or introduced to you the ways that we can combine exponents using multiplication and sometimes addition. Today we're going to start with division, right? You can see these fractions here. We're going to start with division and see if there are any rules there. And then we're going to move into negative exponents. Very interesting. So let's see what we can do. You have this table here where each of these has a numerator and a denominator for the fraction. What we're going to do is in the middle, very similar to last class, you're going to write out the numerator and write out the denominator. So, taking a look at our first one, I have two examples for you. 7 to the 4th is written out with 4 7s, right? We can see 1, 2, 3, 4. And 7 to the 6th, of course, has 6 of them. Now, one thing we need to remember is that whenever you have a fraction with only multiplication, right, we could actually split this fraction up, these 7s, as 7 over 7 times 7 over 7. Here's a third one. Here's a fourth one. And so notice that takes care of these 4 7s right here, but there's still 2 left. And those are both in the denominator. Now, we could put 1s up here. Whenever you have a fraction with nothing on either the numerator or denominator, you can always put a 1. And this crazy looking thing up here is actually the same as this fraction down below, because for fractions you don't need common denominators to put them together. So you could split this into individual fractions or you could put it together. The reason I'm showing you this though is because we need to remember that when you have a number divided by itself, a number divided by itself always makes 1. And so actually each of these fractions are 1s. These guys are not. The way that we're going to show this, though, is instead of going through and splitting and making all those individual fractions, way too much work, we're going to go through and we're going to cross them off. So I'm going to take these two 7s and put a slash through them. What that slash means is we're actually taking 7 divided by 7 and we're making 1. So I'm actually turning this into a 1. Right? Another way you could think about it is these individual fractions you're dividing by 7, and so you're getting the fraction 1 over 1. But 1 over 1 is just 1, hence the giant 1 down below. So here's another 1, here's another 1, here's another, and then we have these 2 loner 7s that are hanging out. So if we reduced all these to 1s, well, what happens? Well, if you just multiply 4 1s together, doesn't it just become 1? And this just becomes 1? And in fact, with multiplication, I think we usually don't even need to write a 1. 1 times 7 is really just 7 times 7, or 7 squared. And all the ones that are on the top just become a placeholder 1. Now, realistically, we usually don't write all these 1s. So let's look at one more example to see if we can do this faster. A to the 8th divided by a to the 5th. Here are these a's, and we're going to start canceling or crossing some of these out. I was able to cross out 5 on the numerator and denominator. That leaves me with 3 a's. You can totally put a 1 in the denominator here. And so, we can say that a times a times a over 1 is actually a cubed over 1. But we should also realize with a fraction, anytime a fraction is over 1, then that's really just a cubed. And so this would be the more common answer. You should note, though, that 1 over 7 squared is not 7 squared. If there's a number in the denominator of the fraction, you can't just leave off the 1 up above. You can do it with the denominator. You'll also notice here I didn't write the individual 1s. Nobody does that. You could write 1, 1, 1, 1, but if they're just going to be irrelevant anyways, just leave them off. So, I have 4 more problems very similar to this, and here are your 4, right? And then I have 2 somewhat bonus problems at the end. Okay, so definitely focus on those 4. You should be able to get through them pretty quickly. And then the 2 bonus ones, think about it. I gave you the answers to the 2 bonus ones too, just to see if you can get there. So, good luck with this. I'm excited for you to give it a shot. And once you have, unpause and we'll come back together. Ready, set, go. All right, you're back. Let's go ahead and check these out. So we'll start with negative 2 cubed. That means we have 3 of those negative 2's multiplying, and I'm trying to be careful with my parentheses. We usually use those with negatives so we don't confuse them with minuses. And then negative 2 squared means 2 of them. We can cancel out these 2. And so this will just give us a negative 2 in the numerator. What's in the denominator? Well, nothing. So you could put a 1. However, we would just write this as negative 2 because we don't need to put the over 1. Let's go again. Z over z to the 8th. Well, z, that's just a single z. So we have z on the top. I meant to switch colors here. Let's give that a second shot. There we go. Z on the top. And then we have 8 of them on the bottom. 1, 2, 3, 4, 5, 6, 7, 8. And it looks like we can cancel or reduce 1 on the top and bottom. So what do we have left? Well, the top of the fraction, we need that 1 as a placeholder. The bottom, I see 1, 2, 3, 4, 5, 6, 7 of those z's, so that is z to the 7th power. All right, next one. We have negative 3 squared over, negative 3 to the 9th. We have to write 9 of these out before we can find our answer. And of course, realistically, what we're doing here is we're going to try and find a faster way to do this. That's 6, here's 7, 8, 9 over here. We're going to try and find a faster way, but for now, we might as well write them out just so we can cement into our heads what we're trying to do. Okay? So I see those guys are gone. The numerator, just a 1 as a placeholder. The denominator, we have 7 of those negative 3's. And don't forget your parentheses around that negative. Last one. We have, switch colors once more. M, oops, I almost wrote m squared. M times m divided by 6 of those. 2, 3, 4, 5, 6. There we go. Easy enough. We use a 1 as a placeholder, and there is m to the 4th in the denominator. Okay, so that's really the important part of this. These last 2, again, are bonuses, and I am going to go through them just so you can see where the answers come from. However, if you're more interested in the main lesson, you're welcome to skip down. You're probably not going to get asked anything like this in the future, at least this year. So let's tackle these last 2 in purple, and then we can move on to the main event. 2x to the 4th. Notice this 4th power is outside the parentheses. What that means then is we're going to do 2x times itself 4 times. I should have left myself more space over our, I should have moved this to the left, but that's okay. 4x to the 5th means, of course, 5 of these 4x's. There we go. Now, this only has multiplication. We saw this last class where you can see that there's multiplication everywhere in here. And with multiplication, you actually can do 2 things. First, you don't need parentheses anymore. And second, you can do the multiplication in any order. So that's what I'm going to do. I'm going to rearrange it and put the 2's first, and then all the x's at the end. 1, 2, 3, 4, and I'll put the dots after. Same thing with the 4's. There are 5 of those. And there are also 5 x's. Perfect. How can we reduce? Well, we see the answer over here, and that looks kind of weird. So, yeah, it seems like everything in the numerator reduced somehow. Well, we have some x's here. I think we can at least reduce these, right? And there is a single x that remains. That's easy. But how do we get 2 to the 4th and a lone 4? Well, remember what I set up above. Each of these are actually like individual fractions. And so if you treat them as individual fractions, I'm just going to use the space up above. 2 fourths, 2 fourths, 2 fourths, 2 fourths. Then there's that extra 4, so 1/4. Can't you reduce each of those fractions? Doesn't this fraction become 1 over 2, 1 over 2, and so on and so forth? So instead of crossing these out, so they don't cancel here, we can reduce these fractions. This becomes a 1, this becomes a 2. 1, 2, 1, 2, 1, 2, and then the 4 stays. Can we see now that the numerator only has 1s? That's where the 1 comes from. And we have 1, 2, 3, 4 2s, and then an extra 4 that's hanging out. Right? Nothing too bad, yeah? Let's try one more. This one goes a little faster. You might at first glance look at this and go, oh, it's the exact same problem. But then hopefully you take a glance over at the answer and realize that's not the same answer. How is this problem different? Well, it's all about the parentheses. This x has a 4th power, this x has a 5th, The 2 and the 4 are not attached to that power. Here the 2x were to the 4th. Here it's just 2, and then there's an x to the 4th. So when we write out the numerator, there's a 2, and then x to the 4th. Denominator, there's a 4, and x to the 5th. Okay. Reducing, we can undo those x's, not bad. We can see that x that's hanging out here. And then notice we just have the 1 fraction, 2 over 4, which reduces to 1 over 2. 1 in the numerator, 2 in the denominator. Okay, now let's circle back to the ones that I highlighted in green over on this left side. And what we're going to try and focus in on are how can we get from here over to here quickly. Well, as a hint, you might remember last class, and I'll give you an example just up at the top from last class. We had something like x cubed times x to the 4th, and we said that was x to the 7th. We added the exponents. When we were multiplying, we add. So if we're dividing, which is the inverse operation to multiplication, what do you think you'll do with the exponents? Well, hopefully you started to notice there was a 1 and an 8 here. We ended up with a 7, right? So 2 and a 9, we also ended up with a 7. There was a 2 and a 6, we ended up with a 4. Yeah, so we really should be noticing it looks like subtraction is our answer. So could we say subtract the 2 exponents? And that works, that's good, but I think one weird thing is going to happen. So let's maybe try the method first and see if we can investigate why or how or when the weird thing happens. So we'll start with x to the 7th over x squared. Instead of writing out 7x's and writing out 2, we're just going to take the 7 and the 2 and say we're going to do 7 minus 2, which is x to the 5th. So that is meant to write as x to the 5th as our final answer. X to the 7th over x squared, it is x to the 5th, that is correct. We just do 7 minus 2. But if we take a look at part B and we do 3 minus 7, right, we did top minus bottom on the other one, so we continue, we get negative 4. And that's weird. We haven't seen negative exponents before. Now we know positive exponents mean you take a number and you multiply it by itself that many times. So what could a negative exponent be? And I was really pleased. One of my very astute students this year said, oh, negative exponent, well, if a positive means multiply, a negative means you divide. And they're kind of right. How do you divide by yourself multiple times? Well, it's, and we should actually probably take a look at this up here. If I wanted to write this out, and I'll do x cubed over x to the 7th, 3, 4, 5, 6, 7. I'm just doing this problem up above, right? We can reduce these guys, and we end up with 1 divided by x to the 4th, right? We're taking, in fact, 1, and we are dividing 1 by this number 4 times. We're doing 1, and we're dividing it by x times x times x times x. So that's the equivalent of 1 divided by x, divided by x, divided by x, divided by x. Okay? And so x to the negative 4th is actually 1 over x to the 4th. So could we maybe come up with a shortcut here? Like if we subtracted the exponents and got a negative, how could we rewrite this so that the exponent was positive so it made more sense to the general population? Well, and you might say something like move the number with the negative exponent to the denominator. And so far, you'd be right, right? X to the negative 4th. Technically, this is over 1. It's in the numerator. We move it to the denominator, and now it becomes positive, right? That's all we need. So just to make sure you're comfortable with this, let's go ahead and fill in this table down below. And there's some positive exponents, 0 exponent, and some negative exponents. Okay? And we're going to go ahead and fill in what each answer is as a nice whole number, or, if you get the chance, as a fraction. We are not going to get any decimals. And that could be a little bit tricky depending on on the problem. So why don't you guys go ahead and give this a shot, and if you get stuck, unpause and we'll see what we can do. Ready, set, go. Now, a lot of my students used a calculator on this, and I thought that was awesome. So they did that 4, and then they used the caret button to the 4th power, and they found that 4 to the 4th power was 256. This was 64, 16, and 4. I'm going to skip over 0 for a second, and we're going to look at the negative exponents. Because if you type any of these into most calculators, you'll get usually a pretty gross decimal. But I think we know how to make these fractions. I'll focus on 4 to the negative 4th to start. 4 to the negative 4th, I could quickly rewrite as a fraction 1 over 4 to the positive 4th. And if I wanted to go a step further and actually find 4 to the 4th, well, look, we did that at the beginning. 4 to the 4th is 256. 4 to the 3rd, well, I don't even think we need this intermediate step. 4 to the 3rd, we know 4 to the positive 3rd is 64, so 4 to the negative 3rd is 1 over 64. Right? As soon as you know the positive version, you know the negative version. 4 to the negative 2nd is 1/16 and 1/4. But then things get a little bit strange. What is 4 to the 0th? Well, if you try that on your calculator, I think you're going to get a strange answer. You might be tempted to say the answer is 0, but it actually turns out that our answer is 1, and your calculator will tell you that. How come? Well, there's a few ways to look at this, and I'll give you 2 different ways. First, you can think about the pattern. Right? If you start at 256 and you move to 64, you actually end up dividing by 4. 256 divided by 4 is 64. If you divide by 4 again, you get 16. And if you continue to divide by 4, you should get every number in this pattern, right? Division is the opposite of multiplication. So exponents are multiplication moving forwards and division moving backwards. So if you get to the next one, you need to divide by 4 again, and that gets you to 1. Divide 1 by 4, you get to 1/4, and divide by 4 again and again, and it continues the pattern all the way out. So one reason 4 to the 0th is 1 is because it just makes the pattern work. However, the other reason that I like to think about is I think about this as the starting point. 0 is neither positive nor negative, so the exponent doesn't mean multiply or divide by anything. I like to think of 1 as the starting number for any exponential pattern. And in fact, 2 to the 0th is 1, and 3 to the 0th is 1 as well. And I think if you move to the left into the positive exponents, it means you take 1 and you multiply by the base. So 1 times 2 is 2, times the base again is 4, and then 8, and then 16. So moving to the left, we started at 1 and started multiplying by 2's. Moving to the right, now we have negative exponents, which are like division. So we start at 1 and we divide by 2. Divide by 2 2's, 3 2's, and divide by 4 2's. Right? Positive exponents multiply, negative exponents divide. So filling in the last one, if we multiply by 3, right? Or if we divide by 3. Perfect. So let's go ahead and conclude with this and then get you guys doing some practice problems. If you're working with exponents, and I said negative exponents, we're really doing all exponents here. If you find 4 to the nth power, where n is some positive whole number, let's do some examples at the top. We could do like 4 squared, 4 to the 7th, 4 to the 100th, right? Those are all positive numbers for n. You just multiply 4 n times, right? So if it was 4 to the 7th, you do 4 times 4 times 4, 7 times. However, if you get a to the 0th, right? A to the 0th, we should know that is always 1. And so a few examples for you. If you had 4 to the 0th, that's 1. Negative 2 to the 0th, that's 1. 100 to the 0th, that's also 1. Any number to the 0th power, 1. That's like our middle, our starting point. How do you rewrite 4 to the negative n as an expression with a positive exponent? Well, you do 1 over 4 to the n. So a few examples here. If you had 4 to the negative 3rd, it would be 1 over 4 cubed. If you had 4 to the negative 10th, it would be 1 over 4 to the 10th. There are no negatives involved here. It's all about multiplying and dividing from 1, and because you start at a positive number, your answers will always be positive. Now, math has been around for a long time, and calculators have not been around for a long time, right? Calculators have only become really prevalent, really popular in the last, I'd say even 10 or 20 years. They've been around for 50 or so years at this point, probably more than that. But realistically, there was a time, even when I was in school, maybe 15 years ago or so, where there was always you're not always going to have a calculator on you, and that's just blatantly false these days. So there's some weird rules, and maybe not rules, but weird expectations in math that have been set because we haven't always had calculators, and they still kind of make sense these days, but if you're like, why are we doing this? That's going to be the reason, at least for today. So, for example, in math, it's considered a no-no to have negative exponents in your answer. And so, what students have had to do forever, and including now, is we do need to be able to rewrite these negative exponents as positive versions that give the same answer. And we already know how to do some of them. For example, 4 to the negative third we know is 1 over 4 to the positive third. And that's fine, right? You could, if you really wanted, evaluate this. You could do 4 to the third, that's 64, and get that as an answer. However, a lot of us will just stop here. It's a little bit quicker. But either way, positive exponent, and over here we don't even have an exponent, which is totally fine. What would happen if this is in the denominator, though? Well, a hint, 4 to the negative third is actually 4 to the negative third over 1. We can put anything over 1. And so when we move 4 to the negative third to the denominator, the 1 is actually still there. There's an invisible 1 that stayed here, but 1 times anything is just that thing. So when we take 4 to the negative third from the numerator and move it down, we end up with something, and then 1 times 4 to the positive third. Well, if there's nothing left there, though, we know we can always put a 1. Now, why am I showing you that? Well, over here, it turns out, and we can go more in depth later on, that if you have a negative exponent in the denominator of the fraction, you just do the opposite of this. We take 4 to the negative third and move it up. And so what's going to happen is this 1 stays here. 4 to the negative third becomes 4 to the positive third. We still have a fraction line. And then if there's nothing left in the fraction, we put a 1 as a placeholder. Of course, do we really need to write 1s? Certainly not. And this just becomes 4 to the third. Or, if you wanted, 64. So, quick summary. If you have a negative exponent in the denominator of a fraction, move it to the numerator, and it becomes positive. If you have a negative exponent in the numerator of a fraction, we move it to the denominator, and it becomes positive. By the way, and this will come up next class, the opposite is true as well. If you had something like 1 over 4 to the third, and you wanted to move it up, that would just become 4 to the negative third. Right? If it's positive, it becomes negative. If it's negative, it becomes positive. Let's look at this last one. 4/7 to the negative first power. Well, we're actually going to be able to solve this one using what we learned last class. We learned with fractions, there's technically invisible 1s on each of the values of the fraction. And so we're going to take this number on the outside and distribute it to the exponents on the inside. 4 to the negative first divided by 7 to the negative first. Except we still have negative exponents. Arguably, we have more negative exponents. So let's make them positive. 7 to the negative first will move to the numerator, and that will give me 7 to the positive first. 4 to the negative first will move to the denominator, and that will give me 4 to the positive first. And at that point, you're pretty much done. You can clean this up, of course. This just becomes 7 over 4. And you could even argue that this is 7 over 4 to the first power. In fact, it's very, very similar to our original problem, except they switched, and now instead of a negative, our exponent has become a positive. And so with any fraction, our negative is just going to flip it and keep the exponent. All right, so I have 6 questions here, and I'm curious to see how you do. Your goal is to rewrite each of these so that there are no negative exponents. Once you've tried them, or if you need a hint, you can unpause and see how you did. I'm excited to see your success. All right, let's take a look. First problem, we need to rewrite this as something with a positive power. Well, hopefully you just did 1 over 6 cubed, and that's it. If you wanted to go further and you knew that the answer was 1 over 216 or used your calculator, that's fine too. We are going to try to keep these answers as fractions though. I think with decimals you lose track or sight of the pattern that we're trying to apply here. All right, 1 over 5 to the negative third, we want that to be positive. Well, we're going to take it from the denominator, move it to the numerator, and this is just 5 cubed. Or if you want, 125. Next one. Well, I think we've learned in the past that we're allowed to distribute powers. So this becomes 2 to the negative 6th. Or to rewrite 1 over 2 to the 6th. And that looks good. If you wanted to do 2 to the 6th, well, 2 times 2 is 4, third 2 is 8, fourth 2 is 16, fifth 2 is 32, sixth 2 is 64. Moving on. All right, there are a couple ways to do this problem. I'm going to show you the way that I prefer. We're going to remember, hopefully, that a negative exponent is going to give us the reciprocal, the flipped over version of this fraction. So 2/3 to the negative second is actually going to become 3/2 to the positive second. I basically distributed the negative, which always causes our fraction to flip or become its reciprocal. Then I'm going to distribute the 2 to both of these. We get 3 squared over 2 squared, and we finish off with 9/4. All right, next one. X squared over y cubed to the negative third. I'm going to do this in a different way than the fourth problem just to give you a separate view. Instead of doing the negative first, I'm actually going to take this exponent and do the whole thing at the beginning. I'm going to distribute, which means, of course, multiply. X to the negative 6th divided by y to the negative 9th. To make everything positive, we take wherever the negative exponent is and move it to the denominator. Take the negative exponent, move it to the numerator. Those become positive, and we end up with our answer. You could also see that this negative would have flipped those to bring the y up and the x down, and then you could have distributed the 3. Last but not least, and this one is a little bit tricky here, I'll go ahead and distribute the exponent again. I think that'll make this a little bit more clear. That's going to give me 3 to the positive second, x to the negative fourth, y to the positive third. Now this is a little bit strange, and I saw some students try and move everything here. We have 3 different terms. We have 3 squared, x to the negative fourth, and y cubed. Only one of those terms is presenting an issue. That's the x to the negative fourth. That's the only thing with a negative exponent. And if there's only multiplication here, or division, I am allowed just to move the single term. This will give me 3 squared, there's nothing left up top, y cubed, and x to the fourth. You could also say that 3 squared is 9, of course. All right, so that's enough of me talking. Let's do a quick conclusion, and then you guys have 12 practice problems on the next page to get through. So we'll start with those rules. If you have a base to a power divided by the same base to a power, then to simplify, we can just do a to the m minus n, right? This is basically just subtract the powers when dividing the same base. All right, a to the negative n, well, we've seen this before, this becomes 1 over a to the n. Yep, and so I'm actually going to say negative exponent in numerator, because this is over 1, right? Numerator, move to denominator. However, if you have a negative exponent in the denominator, move to the numerator. And last but not least, right? This just becomes b over a to the nth power. Or you could say it's b to the n over a to the n, right? A negative exponent gives reciprocal, I have to sound it out every time, gives reciprocal, I'll say gives the reciprocal of a fraction. All right, so you have 12 practice problems on this last page, and I've actually given you the answer as well. Your goal is to show me the work that takes you from here to here. Some of them are pretty straightforward, others are pretty tricky. If you get stuck on any of these, ask me, ask your teacher. Also let me know if I made any mistakes. You guys are going to crush it, and thank you for getting through our lesson on an introduction to negative exponents. Next class, we're going to cover the last type of exponent that we haven't discussed. We've done positive exponents, 0, and negative exponents. What other numbers are there? What about decimals and fractions? And that's that. So lesson 6.3 is going to be all about fractional exponents. Thanks for tuning in, and I'm excited to have you back next class.